Now oscillators operate typically on the tank circuit. Now the tank circuit consists of an inductor and a capacitor that is going to connect to a supply. When I close switch 1, current is allowed to flow, and that causes firstly the capacitor to become charged, as well as a magnetic field to be created on the inductor. When I open the switch, remember we have now received an increase in voltage because the capacitor has charged. When I release the switch, what happens is this capacitor now discharges. We're looking at electron current flow, so as the capacitor discharges, it maintains this magnetic field on the inductor as the voltage decreases. Once the capacitor is completely discharged, this magnetic field on the inductor is going to collapse. Because it collapses, it induces a back EMF which charges this capacitor in the opposite direction, giving us a reverse voltage on the output. So this capacitor is now discharged, or the inductor's lost all its magnetic field, and as a result it has charged a reverse voltage on the capacitor over there. Because there is no more potential, this capacitor now has to discharge again, and it does that through the inductor, which in turn creates a new magnetic field in the opposite direction, but in doing so it loses that electrostatic charge, bringing its voltage back to 0. Now when this magnetic field collapses again, what's going to happen is the inductor is going to charge the capacitor back in the original direction. Now due to losses and due to imperfections in the components and the tolerances, this sine wave that's generated by the tank circuit will constantly decrease with each cycle. So to avoid that, we connect this into a switching and amplification circuit to maintain that amplitude that is generated. If I want to determine the frequency at which this circuit will operate, I need to remember the resonant frequency formula, 1 over 2 times pi times the square root of L, which is the inductor's total value, and the capacitor's total value, which will give me my resonant frequency for this circuit. First application of the Colpitts Oscillator, of the tank circuit, is the Colpitts Oscillator. This section over here, we see a normal amplifier circuit. This transistor can be replaced with a field effect transistor. The base resistor's function is to bias the transistor into the active region. RC develops a potential divider so that we can measure an output voltage, and RE along with CE protects against thermal runaway. We see in this circuit that we have got positive feedback, and as a result this circuit will tend to reach saturation. We can also see that the center point between these two capacitors are connected to the 0 volt. As a result, that voltage there will always be 0, and then the two opposite plates will result in an overall voltage potential difference that we will see on the base of the transistor. Now looking at the tank circuit, we see C1 and 2 is connected in parallel with the inductor. So this forms my tank circuit. So if I want to calculate the resonant frequency for this, I need to remember that I need to work with the total capacitance. So my resonant frequency for this circuit is going to be equal to 1 over 2 pi L C total, where C total is going to be equal to C1 times C2 divided by C1 plus C2. Now the operation of this circuit, when I connect power, the transistor will activate because of the base biasing resistors. That will cause a positive to feedback over there, and a negative because of the charge. That negative over there will turn this transistor more off, so my output voltage will start to decrease. No, because it turns more off, the voltage increases, which causes that voltage to increase. That will continue until my inductor reaches saturation. The transistor reaches saturation because there's no more feedback occurring, no more change in voltage. The inductor will cause the transistor to the capacitor pair to start to discharge. As that occurs, this voltage is going to decrease. We can see C1 is in parallel with RB2. So as that voltage decreases, my transistor switches more on. Because that negative is now becoming 0 volts, transistor switches more on. Because it switches more on, its voltage decreases. Because of that decrease in reverse voltage, the capacitor will continue, or the inductor will charge this capacitor due to the back EMF, causing a positive there, and this side to become more negative. That positive turns this transistor more on, which in turn sends it into the negative half cycle. That feedback signal will continue until the saturation is reached. Once saturation is reached, the inductor will allow the flow of current again. That causes the capacitor pair to discharge. That in turn will start to turn the transistor on again, which in turn will send it back to 0. As a result, when we put this circuit on power, we will generate a sine wave as an output.